So next up, Gabriel Dos Reis is going to tell us about build time reflection with C++ in the year 2023. Hey, Gabby, welcome. Thank you for coming once again. Have you given a talk every year so far? I think you have.
Yeah, I'm happy to do it.
A
I'm passionate about C++
veteran.
and modules, and anytime.
Great. Well, take it away.
Okay, so as you know, I've been talking about modules since 2015. And back then, I've been busy telling everybody, "Oh, modules are great. Modules are tooling opportunity, and that kind of stuff." So today, I wanted to briefly tell you some of the awesome things that you can do with modules, not just because your code looks better, but what you can do with, let's say, a leftover of modules, not really leftover, but build artifact. When you build your modules, the compiler generates a bunch of satellite files, information that it uses to process the rest of the program. And that build artifact is not just good for the compiler, it can actually be good for you. And one of the things you can do with it is to have your own reflection. I know that in the C++ community, we have been wanting to have static reflection for a while now. And, it might probably take another couple of years or more before we get it. But in between now and then, what can you do? So here, I wanted to tell you, you can do a lot of stuff that don't actually need an upgraded compiler. So a reflection, when the notion of reflection is just the ability of a program to examine, query, introspect, and not just that, but also manipulates its own states and structures and behavior based on the questions that it asks itself. And that's quite fairly general and some degree abstract. But when you look at that definition, you have the notion of, introspection, which is just really query, not modifying anything at all. And indeed, introspection is just that part of reflection. And some people will tell you, "Oh no, introspection is not reflection." But it usually is easier to implement. We already have that in C++, and of course, you have it in other languages. But in C++, for example, you have runtime type information. When you use type ID on an expression or a type, the compiler creates a data structure that it embeds in your program, and then at runtime, you can query the type and a bunch of other stuff. It's something that's quite nice and allows expression of certain ideas. That's quite easy to do, as long as it is well supported. When it's not well supported, that's where you get a bunch of stuff. So the general idea of reflection, introspection, they are notions that can be practiced at any stage of the development of a program, whether it is during pre-processing stage. You know that you can use the string signification operator from the macro preprocessor to get the string of a name, right? And you can do concatenation, so you can actually build more names, more stuff. And in program, you can use trait. We've been using traits since C++11. You can query states of a type or an expression, an object. Declar type is one of those introspection operator. Same is no except. Would an expression raise an exception, for example? So those are properties of expression. And then, of course, you have runtime behavior. If you perform a dynamic cast, for example, that's during program execution, and the compiler is required to generate data that embeds your program in executable, and at runtime, it carries some operations to try to find the right type that you're casting to. And people will tell you, well, reflection is great, but it's not free. It costs stuff. Like compiler really has to embed something in your program, and that can be gigabytes. So sometimes people say, yeah, reflection is great, but I'm not ready to pay the price for the additional object size increase that I'll get at runtime. On the other hand, like I said, we have been waiting for some notion of static reflection for a very long time, and some people are tired. We have systems deployed that have their own meta protocol. If you know the Qt GUI system framework, for example, you know that it has the mock compiler, that meta object compiler, that look at your program and then generate supporting infrastructure to make sure that your slot and signals are connected and everything is working properly. It's just one example. So if it has been taking that long to do, how hard is it really? It's a type, just associated value. How can that be? The truth of the matter is that if we just look at introspection, for example, runtime introspection, we have runtime RTTI, for example, or exceptions. You can think of them as some kind of continuation where you have program point, say program point that you want to jump back to later, and then you turn that to data that you manipulate. Well, one of the things that does is it hinders optimizations, right? The compiler can't reason saying, oh, this thing exists there, I know the structure, and I can come back to it. Well, nobody's going to come back to it. I can right away inline it or move codes around and so forth. So it costs. And furthermore, one of the debates in the C++ community is whether you should ever enable exceptions or RTTI at all, like tap ID, because it makes your program bigger. Yeah, so we know we have evidence that a poor implementation of these facilities can actually be detrimental to actual adoption. And it takes time and effort to implement these things properly. So it's non-trivial investment to make. Now, when we're talking about reflection, so remember, introspection is just ability to query, observing without changing the state. But reflection, you not only doing query, but you also want to modify the behavior of the program or generate new stuff based on what's new. Well, it's an order of magnitude at least much more difficult, in terms of deployment, implementations, and so forth. And once you have a reasonably good reflection system in place, it becomes much harder to evolve the language, because, well, some of the construct that you knew when the program was compiled, they were turned into data embedded. And if later you embed it in your executable, if later somehow you bring in component that was compiled in the future or in the past, and they do not agree on the protocol, well, you get into real trouble. So once you have reflection in there and features or functionalities that are reflected become much harder to evolve properly. So that led to people to say, well, we don't really want runtime reflection because, we know it makes the executable much bigger and it has a bunch of other stuff. Well, we just want static reflection, which just means that during compilation, we know the state compiler already has those information as its own data structure. We just want to be able to to poke a little bit and then ask the compiler to generate a little bit more code, but based on what is known at the time of compilation. So the evolution problem is a little probably more reduced, but you still have, substantial work to do on a compiler. So we know compiler writers, C++ compiler writers, we can fit them in a room. And then we have millions of C++ programmers. So if you can just get a couple of people suffer for the greater good of everybody else, so be it. So that's good. And having static reflection, mitigates, many of the drawbacks that I mentioned earlier, including performance and space, which is part of why the standards committee and the community as a whole have been pushing for this notion. I am here to talk about build time reflection and not static reflection. And some people will rightfully say, what the hell is this thing that I'm talking about? Well, it is not a new language feature. It is not. What it is just just being, very responsible with the resources that we have. So the idea is that as we're building the program, during build time, we generate build artifacts, and we would like to be able to augment the program, the final program, with information that we know during build time. So we can generate new code that gets compiled and linked with the rest of the object file that already exists to create the final program. So it really involves build time code generation, and it moves the burden from the compiler to the programmer. So if you're interested in reflection, one of the questions that you should ask yourself is, how much of the work that I'm asking compiler writers to do can I take on myself? And how much of that can I get the community, help develop? And that is what, this is about. Now, what can you do based on what is known during build time? And so the way, if you want to do build time reflection, you have to structure your program build in a certain way. You start with already known source code. It could be human authored or machine generated, and then you compile those things, and then let's say, for example, we have module interface source file. When you compile it, you get what we call build module interface, or BMI. Or if you're using MSVC, we'll say you have an IFC file. Well, that build artifact contains a lot of the semantics information that compiler knows. And it is possible for you as a programmer to go and crack open it and then generate new C++ source code that you can now get fed into the pipeline of build pipeline to augment your program. And you do this, iterate this process as long as you need till you don't need to generate more stuff. And then when you link everything together, you get a system that is fairly powerful. It doesn't give you everything that static reflection will give you, but my hypothesis and conjecture is that it gives you nearly about 90% of what we have been waiting for. So it's a good thing to invest in. For this to be successful, you have to be mindful that because you're generating code, your build system how to support, automatically generated code. Most build systems support that. And if somehow you're still writing your own build definition by hand, maybe this is the time to reconsider your choices and see if something else can help you there. Okay, and another way of looking at build time reflection is it's some form of grain computing. Like you imagine you're using all these things, and then something was generated as a necessity, and you're not letting it go to waste. you're reusing that information, the same information that the compiler had before. You too can have that. And with modules, it's there anyway. Like, it's not additional work that we are asking the compiler. The compiler already did that work. So we're just being very responsible with the resources that we have. So now I want to just illustrate the idea of build time, reflection by using a very, very simplified example. The idea is not so much that I want to trivialize the problem. It is to convey the basic of the idea. Once you get it, I trust you that you'll take it and run away with it and make it as complicated as you want. That I trust you with. So I'm just going to use a very, very simple example. So don't discount the example. Just think of it as just a way of doing something. It's a template, and you can use it and magnify it, instantiate it in other situations. So the example that I want to look at is, imagine that you have a program, you're writing a program that has a bunch of types, and somehow you need to do a lot of formatting, IO formatting, because you're sending data, you're doing distributed computation, you're sending data over network, or you're saving data on file and then reading it back later. Imagine you're doing game development and you want to save some characteristic of characters in your game, or skinning and so forth. Well, how do you do that kind of IO thing automatically so that you don't spend your time? You spend your time actually programming a game as opposed to doing work that is best left to machine. So the example I'm going to give you is using, of course, modules. And what I use? So for this to work properly and to scale, we can't just go through the entire program and then generate IO formatting function for every single type that we find in the source file. That just doesn't make any sense. If I don't know if it will compile, and if it does, it will just be waste. So we need an ability to annotate in this source program, hey, I need something to be done automatically for this type. Okay, so we need a hint, whatever it is. If you were designing a new programming language, we probably need a keyword or something. But remember, I'm not here to talk about a new language feature. I'm here to tell you what you can do with the existing language. When I say existing language, I'm mostly thinking about C++ 20, C++ 23, which should be out very soon. And you already have compilers out there supporting most of C++ 23. So the ability to selectively tell the tool, the system, to generate certain code for something will help reduce code bloat. And by doing so, we'll also improve efficiency, overall efficiency. You know that space is time. If your binary is big, it's probably going to eat up a lot of space, cache lines, and so forth. So take this very simple example. Imagine I'm dealing with points on the planar geometry, and I have a struct point. And the usual thing, have a coordinate, x and y. Of course, I will go and write my own formatting function, but it's boring. It's boilerplate. We want to increase your productivity. We want you to delegate that boring aspect to a tool. Just define your abstractions and we'll take care of the rest. That's what reflection is really good at. So in the example that I'm showing here, like I said earlier, we need a way to annotate. So here I'm just using an attribute on the type definition here. Now struct point to D, have this attribute say GDR generates output. So this is just some kind of DSL for me to tell the tool to generate IO functions for this type. I don't want to write that function. I want the tool to write it for me. And what will happen when I do that is something like the following. The tool, this tool that helps me use build time reflection, will generate a new module source file. It will take the input module here, so plain.geometry, and it will use that name and then as basis, and then we'll add reflected.output. Usually when you have tools, it's good if they can predictably name things, right? And then the next thing it does, all this is generated source code. I say import stud. Remember, with C++ 23, now you just say import stud, and then you move on, do whatever you need to do. And you can use this thing today. Like import stud works today if you download the MSVC compiler and using either MSBuild or using CMake, it will take care of all of that. And then the next thing it does, the tool does, is generate this function, operator less than, takes an IO stream and point to D, and then formats the coordinates of the point in a stylized way. And if you look at the code carefully, those places that are green text, you'll know that they're entirely determined by the structure of the class, the struct that's here, the name members, and that's all. So it is purely mechanical, and this is something that a tool should do for you. You do not need to do it. The fact that the base language does not have this facility built in is a shame, but it's okay. We can get the tools, take care of those things that can have here. So like I said, this is just a simple example, but imagine you do not want a formatting like this. You want, let's say, in JSON format. So you'll have your tool generate the codes using JSON library, or if you want to have a binary representation on disk, or you want to send over to network, all those things, they are boilerplate that have structures, like they are templates that can be done automatically for you. And the only thing that so this is source code that's generated by the tool, and I have to make sure that my build system knows that this source file is going to be generated by the tool so that it schedules its build properly. The other thing that I, as a programmer, need to do is just to write my main program that's using this thing. So plain geometry, that module is something that I authored, that was input into the tool. Then the tool will generate automatically for me this other module, plain geometry reflected output. That now I can just import stud again, and I can just use the insertion the formatting operator that was automatically generated based on the structure of the class that was defined. So this is a concrete example. It is simple, I agree, but what I'm trying to convey here is not how sophisticated it is, but how simple things can be. Okay, and most of your complicated situations where you want to have static reflection, you can structure the code in a way that you can actually use build system by carefully putting and design the interface so that you can have this cycle that I mentioned earlier, how you orchestrate the build. So the summary, of course, the IO stream example is simple, but it is a template. Again, it's a template you can use. You can generate JSON, YAML. If you're doing gaming stuff is where you have a lot of need for reflection stuff, because you have types that you define in your source code, but they represent stuff that you want to, associate properties with, and in a way that is mechanical, so you can actually have the tool do these things for you. These functions that are doing the output function, they are automatically generated, so they are always up to date with respect to the type definition that is in your program, right? So you don't have to worry about it. And also, if you happen to change a field or something, you don't need to go and hunt 25 places to try to change those things. The tool can just automatically generate everything for you. And you can deploy this today. We do not need to wait for matter 2, 3, or 5 years, or I don't know, decades to get reflection in the code, because this is simple enough that it can be taken care of. And you can have your own, like if this doesn't work for you, you can have your own generator based on the logic and the needs that you have. That's the beauty of it. You do not need to go and extend the compiler. You just need the compiler to tell you, hey, while I was building that module, this is what I found. Is that useful to you? And say, oh yeah, great. Give that to me. I know how to use it. Okay, so all of that is kind of very high-level description of how the code is generated. When you're using the MSVC compiler and you build a module, it generates an IFC file, what we call builds module interface in standard terminology. The MSVC format, that the IFC format, is publicly documented. As a matter of fact, we want the community to really, use it, extend it, and however they see fit. A couple of years ago, I gave a presentation about how you can actually decompose an IFC file, and in another talk that's interesting that for you to see is one given by my colleague Cameron De Camera, in the way he showed, a viewer of an IFC file written entirely in JavaScript. So it's not even C++, right? So when we say modules are tooling opportunity, your tool doesn't need to be written in C++. It can be in any language you want, as long as you can read a binary file. Okay. The last thing that I wanted you to know before I go out is, please start using modules today, especially with C++ 23, where you don't need to remember which header file you need to include, this and that. Nope, just say imports to, done, boom. And furthermore, it is much faster. The build time is improved because the stud module, it's built once, it's reused many times, so the compiler doesn't need to reparse all the time. It is simpler to use as PCH. If you're on PCH today, I really invite you to start considering using modules. And if named modules are a bit too steep a step for you, probably start with header unit. But really, what a game is not named modules. There is to be a GitHub repo that contains all the source code that can use as inspiration that demonstrate what I just talked about. And please clone it, extend it, use it any way you want, and give me feedback. Well, what else would you like to see? Do you want an SDK? How? What are you going to do with it? Let me know. And finally, the IFC spec is there on GitHub as well. It's for the community to evolve, contribute, and give feedback. With that said, I'm ready to take questions.
Thank you so much. So we've got a few questions in chat. We have one from Antonio, which says, reflection is a fish hard to sell. Why not show some code? You showed some code. This was from about halfway through. What arguments do you have on what there is to gain by using reflection? What are the use cases for reflection in C++?
Oh, okay. Yeah. So not everybody needs reflection. But the first thing I have to admit now, clear, not everybody needs reflection. In the talk, I gave the example of formatting. And that's just, every time you're doing IO, many of these types, they have a full certain pattern and they're very repetitive, and you can get that automated. If you're doing gaming, you have types, the characters in your game, they tend to have properties, values associated with them, and you can have that saved on disk and read back automatically. Again, the way you do that is very repetitive, very structural, and best done by tools. If you're doing distributed computation, these days we talk a lot about AI. Well, AI is very compute intensive, and the work, when you're doing the work, the best way you do it is you distribute the work. So you have to send data over network. How do you get that done properly? And making sure that the data you're sending, the structure, everything is in sync. Best use, reflection to take care of that for you. So it's not so much reflection in itself. It's a tool to take care of boilerplate so that you can focus on the most creative aspect, the joyful part of programming.
Thanks. And then we've got a few questions from Milos, who says, do we believe static reflection would allow us to finally get rid of macros, or are we cursed with hash-if defined __ clang for the rest of time?
Well, okay, so modules take care of a good chunk of the macros. So the if dev, that kind of stuff, taken care of by modules. Now, when we're talking about compiler-specific characteristics, like certain features are available only on Clang or GCC or MSVC, those will still be there. But when we're talking about code generation, one of the things I don't like macros, but I also have to confess I use macros as a way to generate codes, like generate sequence of tokens that are compiled by the compiler. Well, my sincere hope is that we will get a good static reflection system that will take care of that huge swath of need for code generation. Then what is left is probably unstructured code. Sometimes you just want to include some text. It has no structure to it. Well, you still have to use macros for that. But having something that plays by the language rules, that your IDE understand, your build system understand, is much better than having this, character string manipulators.
Yeah, for sure. And the reflection repo, you're going to push that live after the talk, right?
Yes, yeah.
Cool. Another question is more theoretical, but do we think it would be smart to have a pre-build step that is going to do this generation so that the IDE knows that these things exist?
Yes, I agree. Yes, yeah. That's actually a good point. We talk a lot about what reflections. They're great, but they also add complications to the IDE experience, where certain functions that now available at compile time or invoked at compile time need to be understood by the IDE in order to provide better experience. Yeah, absolutely.
And then another more general one for everyone: any good introduction to compiler development? On that one, I'd recommend the book Crafting Interpreters.
Yes, absolutely.
It's about interpreters, but it's mostly all applicable to compilers as well. You can read that book and then pick up something a little bit more, delving deeper into compilation techniques, like engineering a compiler or modern compiler development in ML or C or Java, whichever one you like for some of the more compilery things. But Crafting Interpreters is just such a well-written and structured book that I'd recommend.
I 100% agree. And if anybody, you should take Sai's advice on it. This is great. And if you do it, you'll find out that if you're writing an interpreter, and you want to do, let's say, IO, for example, because you need to read you'll find out that you need a way to reflect the facilities in the C headers, on the C++ headers in your interpreter. And this is another place where actually reflection help you write simply your interpreter. That's fantastic.
Okay. Second cat of the day here. Actually, her name is Lexical Analysis Cat. So
lexical analysis and
very
marshmallow.
Okay. Yeah. Anchor asks, what compilers does?
It's a question about GCC. Oh, okay. My apologies. The the only reason I didn't mention, so I think on the last slide, I said that use modules today, you have CMake build system support, and they have build system support for MSVC and Clang. It comes in box. For GCC, it's not because, it's more like the necessary support is not there yet, so I didn't want to lead people on something. But, it should also be mentioned that GCC also has support for modules.
Okay, and then there's one more on what compilers does GDR generate work with?
Oh, so all the examples are built with MSVC. So the IFC format right now is very specific to the MSVC compiler. I use my private, network private build to do that. So whatever preview is there as of today will work. I would like to see the community coalesce around a common format for module interface, whether it's IFC or something else, doesn't really matter. But being able to have these tools work, cross-platform, cross-compilers is fundamental for us, the C++ community, to realize the promise of modules being tooling opportunity.
Yeah, and I think that answers the next question as well, which is, could this work be implemented for other compilers like GCC and Clang?
Yeah, so the IFC spec is public, and if someone feels energetic enough to to get a fork and generate IFC out of it, it will work. If you do that, you do not need to change GCC's own internal representation. You do not need to do that. That's going to be a huge amount of work. No, what you will need to do is just ability to translate the IFC data structures into GCC's or Clang's internal representation. I think if I were to do that, that's the way I would do it. I will not sign up for, we need to rewrite GCC or Clang using IFC. No. Just ability to read or write. That's it.
Yeah. And then still got time. So another question is, could the IFC spec be put in the C++ standard?
Probably not C++ 26 or C++ 29. Of course, I would love that. But the reality of things is that for something like the IFC, you need it to evolve as quickly as possible, the way compilers evolve, whereas the standards tend to be on 3 or 6 years roll. So if it could just be some kind of de facto standard, I think that will take care of all the practical needs that we have, and then let it evolve as quickly as it can. And I would really love to see something like that happen.
Great. Well, we are out of questions and almost exactly on time. We stayed on time for the entire thing. Kind of
Thank
suspicious.
You're running this thing quite well.
Yeah, it's our 4th year. We're getting the hang of it.
Yeah.
So thank you very much, Gabby. Thank you for everyone who has stuck around and watched all the talks. These will be put online on the Visual Studio YouTube channel. So please keep your eye out for those going live, and feel free to share them around if you have enjoyed. So thanks very much, and hope to see you all next year.